Hello students, and welcome to Stoichiometry video 2.0. Because this is now my second time recording this video, we're going to pretend that I didn't mess everything up from before. Okay, so what's going to be going on today is that we're going to go ahead and go over stoichiometry. We're going to go over the basic process for it and some of the tips and tricks that I use to go ahead and keep myself sane while going over problems like this. And we're also going to go ahead and do a couple of demonstration problems because I think that's the best way, is just to practice stoichiometry until it becomes second nature to you. So without much further ado, we're going to go ahead and move on down to the next slide, which gives us our rules/procedures. And these are kind of loose rules and more of like a process of what's going on. So our first thing that we're going to want to make sure that we do every time is that we're going to want to make sure that we balance our equation. Okay, that's going to be important because it's going to give us our ratios of moles of different compounds so that we can accurately compare them. Step 2 is going to be to get to moles. Now often what's going to happen is that you'll be given a starting point, and it'll either be in liters, or it'll be in grams, or it'll be in milliliters, and you have to figure out, how much of a substance is based off of concentration. There's going to be a whole bunch of things that it could be. And our goal is going to be to take it from whatever starting unit it is and to get it into moles. And the reason that we get it into moles is that moles is going to be the only way that we can accurately compare compounds of one type of compound to a compound of another. Okay. Once we do that, we can go ahead and compare our substances, and we're going to do that through the coefficients in the equation. And then our last step is going to be to get it out of moles, and that's going to be the process by which we take it from moles in the unit that we want and transform it into the final unit. So if it's asking for grams, we're going to go ahead and take grams of our product, or we're going to take moles from our product and turn it into grams of our product. And that's the basic formula for how a stoichiometry problem is always going to go. And if you break it down and always think about a stoichiometry problem as only being these four things, it should make going through and problem solving the different types of stoichiometry problems easier for you. So without much more, we're going to go ahead and move over to our first question. And our first question gives us an equation, and it looks like we have ammonia combining with nitrous oxide, and it makes N2 gas and H2O. Okay, and it's asking us how many grams of each reactant were there if 13.7 grams of N2 is produced. Okay, so it's giving us this question, and it gives us our starting unit, and our starting unit ends up being in grams. So we'll go ahead and go back to our little workbook here, and in this case the big blue button for some reason has the best drawing program for me. And we'll go ahead and start by writing down our equation. Okay, and it looks like we have NH3. We have added to that the NO, and that ends up making for us the N2 and the H2. Okay, so we have our equation. Now we're going to go ahead and take a look and say, okay, is this balanced? Okay, we have N, we have two N's, we have two N's here. We have H, we have three of them here, we have two here. It means that we're going to have to balance it out. Okay, I'll give you just a couple of moments here so that you can go ahead and balance it out. Pause the video and balance it out on your own. Okay. Now that we have it balanced, we're going to go ahead and move on. Our problem is essentially asking us to solve how much of each reactant do we need in order to make 13.7 grams. So this is a double one, so we'll go ahead and write 13.7. And we start with grams of N2. Okay? So we've started our problem and we start in grams. Okay? We've balanced our equation and now we have to convert those grams to moles. So we'll go ahead and draw conversion. And in this case, because it's in grams, we know that we can convert grams to moles through molar mass. So we can go ahead and put mole on top, grams on the bottom. 1 always goes with mole, and the spot for grams is always going to be the molar mass for N2, which in this case is going to be the 28.01. Okay, our next step is to go ahead and compare compounds. Okay, now we start with N2, so N2 is going to go on the bottom, and then we end up wanting to find one of these two. So we got to pick which one we're going to solve. We'll start with NH3 because it's on top. And the numbers that we're going to fill in for these are going to come directly from our equation. So since this one has 4 in front, we're going to go ahead and put 4. And N2 here is going to be 5. Our last step is going to be to convert it to what unit that we want. Now in this case, it's asking for how many grams of each reactant we have. Therefore, we can go ahead and put the unit here, which is going to be grams. And then we know that we're in moles, so we'll have to get rid of those moles. Okay, and the number 1 always goes for mole. And grams is always going to be the molar mass for the thing in front, which for ammonia is 17.031. Alright, so now what we can do is we can go ahead and solve, and in this case we end up getting 6.66 grams of, and it's always going to be this first compound that's on top here, NH3. Okay, so we've solved our first problem. Okay, the second problem is going to end up being very similar. Okay, but the only difference is that it's asking for a different compound to switch it to. So it's still going to be grams of N2. We still have to get that 2 moles. But now we're not going to compare it to NH3 because we're going to be looking for NO or nitrous oxide. So NO, and the number for NO is this 6, so the coefficient's 6, so we'll go ahead and put 6 there. And then our molar mass is going to change as well. So we'll go ahead and plug in for there the 30.01 and 1 mole. Don't forget our units here. And then this should end up equaling 17.61 grams, and this time it's NO. Okay, so again, this is one of those things where this first one, this is our second rule, this is our third rule, this one here is our fourth rule. Okay, so we had to start by balancing our equation, then we converted to moles, compared compounds, and then got it out of moles. Okay, so we converted out of moles into what unit it was wanting us to go ahead and go to. Now we're going to go ahead and start the next type of problem, and this problem is going to be a molarity problem. Okay, and this problem is having us calculate the number of grams of carbon dioxide from a solution of potassium hydroxide. Okay, so we already have a made solution and we want to go ahead and solve for it. So in this case, what we'll go ahead and do first here is remember not to forget our equation. So let's go ahead and grab our equation here. Okay, so we've grabbed our equation, and then the first thing that we should notice here already is it balanced? Okay, and it looks like from this side here that we have two Ks. We have 2 Ks. We have 2 oxygens, and we have 2 over here, so we have a total of 4 oxygens on the left. And we have 4 oxygens on the right. We have 2 hydrogens, and we have 2 hydrogens on the right. So it's already balanced for us, which is great. Now we can go ahead and move on to our next step. Our next step is to go ahead and convert it from whatever unit that it starts with into moles. Okay? And it's giving us 2 units here. It's saying that we have 135 milliliters and that it's 0.357 molarity of solution. Okay, so it's not giving us grams, which is unfortunate because we know how to do that. However, it does tell us a couple of things that are useful. And the most useful thing is that it tells us that it has 0.357 molar solution. Okay? Now remember, a molar solution, that sounds like it has something to do with moles. A molar solution is going to be moles over liter. So that means if we can find some way to go ahead and get rid of that liter, we could go ahead and have our moles. And luckily in the problem, it also tells us that we have 135 milliliters. Okay? So that means then in total we have 0.35 liters. And now look, if we multiplied these two numbers together, the liters would cancel and we would be left with moles. Okay? So this is what I mean by that second rule in particular, that our goal is to get to moles, and we can go ahead and get to moles a variety of ways. And we might have to be tricky to go ahead and go through it. Okay? So now we'll go ahead and finish out this problem here. And this time we're going to have 2 KOH here, because we're going from potassium hydroxide, and then it's asking for how much CO2 in grams. We'll have CO2 here. We look for the coefficient, and it looks like it is 1. And then we convert from moles, and it's asking specifically in the problem for grams, so we'll go ahead and take 44.01 grams. Then we'll go ahead and put moles. Okay, we multiply the top, divide the bottom, and then we should end up getting 1.061 grams of CO2. Okay, so this one was slightly different in that it gave us the molarity, but because we have our general rule of get to moles, we can go ahead and solve for it. All right, the last type of problem is a problem that's going to be a little bit different, only because it gives us something different altogether. In this case, it gives us density, okay? Now, this problem here, it says that we have 50 milliliters of liquid methanol, and it gives us our density. And the first thing that we should notice is that density comes in grams per milliliters, okay? Now, we don't know how to convert density directly to moles, but we do know how to convert grams to moles, okay? So in this case, what we're going to have to do is we're going to have to go ahead and get it to grams first, and then from grams we can convert it to moles. So we're just relating this amount that we have and getting it back to moles. Now the other thing here is that this problem hasn't given us a equation. So that means that we'll go ahead and have to solve that equation here. So what it's stating here is that we have methanol, and reminder, any carbon compound that has meth in it means 1. So this is going to be C. It has 1 meth. 1 carbon, so that's meth. H3, because it only says that there's 1 alcohol, because it's methanol. And then alcohol groups are always going to be OH, okay? They're going to combine with oxygen, because the problem says that they combine with unlimited oxygen, and it makes carbon dioxide in water. So it's a simple combustion reaction, okay? At this point, go ahead and take some time to go ahead and balance this out, because I can tell you anytime you write one out, you should balance it out automatically. Okay, and then we're going to go ahead and start with the same process. So, just a little bit ago, it told us that we had a density of 0.850 grams, okay? That's grams per milliliter. And we wanted to figure out, and we'll go ahead and put methanol right here. Don't just leave it as meth, otherwise, another teacher might be confused and question chemistry again. Okay, so here it's in grams per milliliter. It'd be nice if we can get rid of that milliliter. Okay, and remember, in our problem here, it says that we have 50 milliliters, so that's convenient. So we can go ahead and put in here 50.0 milliliters. And then it'll end up being in grams, okay? Because those milliliters will cancel out. Which means that we'll have to convert it from grams. So we'll go ahead and put mole here. And we'll put grams, 1 mole. And when we look at methanol and do the math, we'll find that we get 32.01 grams for the molar mass of it. The question is asking for how many grams of water, so we'll go ahead and put 4H2O from our balanced equation. We'll put 2CH3OH, and then we'll finally finish it out by getting out of moles. And our out of moles is 2 grams from the question. So we'll go ahead and put 18.02 and then mole here. All right, and then when we go through and figure out all the math, we should end up getting a total of 47.81 grams of H2. Okay. And this should give us a good basis for which we can go ahead and solve a variety of problems. In general, all stoichiometry problems will begin and end with the same sort of ideal, that we're starting with some unit and we have to get it 2 moles and then convert it from moles to something else. Again, the key is using moles as our method for converting and just sometimes being crafty in how we do that by using dimensional analysis right here. And this process of using milliliters of something to cancel out so that we have grams is exactly what dimensional analysis is. It's making our units do all the work for us so that we don't have to do extra math and figuring. Okay, this should give us a good start for it, and we'll hopefully have more work on this later.